Hello students, my name is Sumit Sagar Hota. I am a PMRA PhD student IIT Palakkad. Today we will discuss lecture 21 to 25 by Professor Ashok Sir IIT Kanpur of the subject Introduction to Airbreathing and Propulsion by NPTEL. This is the week 5 of the live discussion section. In this section mostly we will cover the MCQs and I think one long problem we will solve at the end. Okay. So Ramjet was okay. Okay, so Ramjet was first invented and patented by whom? Okay, who is the inventor of Ramjet? So this type of question may be asked. Ramjet, Scamjet, who are the inventors? All these things. This is one of the type of question which can be asked. Okay, the name of the person is Rene Lorin. Inventor of Ramjet. Then Ramjet is a dash, steady or unsteady combustion, or continuous or not continuous flow engine. Ramjet works on steady combustion. In most of the cases it's steady combustions only, most of the jet engines, because unsteady leads to turbulent instability. Okay, and this is a continuous flow of air and oxidizers are there, and this is a continuous flow engine. Then Ramjet contains a pressure ratio of about what? Actually for Ramjet the pressure ratio is very high. It's actually anyway in 20 to 25 and this 12 to 14 this much high nowhere it's possible. Okay, so these two options are given for confusion. Okay, so high we know, but how much high? It's actually 8 to 10. Okay. Okay. The Ramjet contains a mechanical compressor. Is it true or false? Okay, so there is no mechanical compressor in the Ramjet. Okay, this statement is false. then the ram pressure rise can be achieved in, okay, that means it's telling pressure rise. Okay, so pressure rise means the velocity will decrease. So if the velocity will decrease, that means it will be a what? Diffuser. Okay, so the D option cannot be option. Okay, so is it possible in supersonic or subsonic? Obviously the ram jets are actually worked on both supersonic and subsonic flows, so in both the cases it's possible. Okay, then air entering into the ramjet engine should be dash to prevent the blowout in the combustion chamber. Okay, so blowout is the case where which occurs always in the what? High velocities. Okay, high velocity means your where is the in the place of combustion chamber. Okay, so there won't be any flame formation. Okay, but near the exit there will be what? Flame. Okay, so that's actually the case of blowout. Okay, and most of the cases under higher velocities in any kind of jet, not necessarily ram jet also, this what you called blowout will be there. Okay, so in some in some cases it will be supersonic, and some cases it will be hypersonic. Okay, so that's the reason, but most of the cases higher velocities it will be blowout will be there. Okay, so that means we have to operate in which condition? Subsonic. Although it can work both supersonic and subsonic, but subsonic is preferable for ramjet. The cycle pressure ratio of a ramjet engine depends upon its okay, okay, so so to solve this thing, okay, I will solve it using a what you call cycles. Okay, we're assuming that it's a constant pressure process. Okay, but in actual scenario the pressure can be also changed. Okay, okay. So position where this compressor is there, that position is the ramming, and the processor where the positions or the processes where the turbines are placed, those cases are the cases of what? Jet. Okay, and I actually drawn where the dash I represented the actual cycles, and so because in actual cases it cannot be isentropic. 1 to 2 is isentropic and 3 to 4 is also isentropic process. I actually forgot to mention 3. Okay, so here if you can see, so what actually the question is, the cycle pressure ratio of a ramjet engine depends upon its what? That means ramjet engine means it's talking about the process 1 to 2. Okay, so what we will do, we will take the ratio, both ratios 1 to 2 and 3 to 4. Okay, I am representing not not as the atmospheric condition, not very high pressure or all these things cases I am not considering. Okay, at the normal temperature and pressure condition I am considering. Okay, so P02 by P01. But you know what, the 1 to 2 and 3 to 4, this ratio is always constant. Okay, we are telling it as a constant pressure ratio process. Okay, that we called it as what? Cycle pressure ratio. Okay, so 1 equal to 2, and what is the formula for Mach number? The Mach number is sonic velocity divided by square root of gamma RT. Okay, so Exactly. Yes, Mach number is v by a. That is your v is the sonic velocity and a is the actual velocity. Okay. The actual velocity formula is square root of gamma rt. Okay. So what exactly why I am doing all this thing? If you're really going to see this c, whatever I am representing is the what? The flight velocity. Okay. And when you substitute this one and 2 as same, and m equal to c by gamma rt. Okay, so that means if it will be mi, then the formula will be what? Ci by square root of gamma rt, and if it is mj, then this formula will be cj by square root of gamma rt. Okay, so you have to just substitute here in the equation 1 and 2. Okay, then equate both 1 and 2 equation. Okay, if you're really going to equate all these equations, then one relation we can found it as Cj is equal to Ci into C by square root of gamma rt. Okay. So in general I am writing, okay, if it is what you called if Cj equal to Ci, okay, if this is the actual cases, if for the normal condition the Cj can be equal to what? Ci also. Okay, if you solve this 1 and 2, you will very well get that this whatever power is just get cancelled, 1 and 1 get cancelled, then gamma minus 1 by 2, gamma minus 1 by 2 get cancelled, then the mi square is equal to mj square. Okay, so mi square equal to mj square, then mi equal to also mj if you are really solving it. Okay, then what is mi is ci by square root of gamma rt, and what is mj? Cj by square root of gamma rt. Okay, so then Cj and Ci, then Cj equal to Ci. Okay, but if this 1 and 2 cannot be equal, okay, then this mi we cannot equate this 1 and 2 equation, and in that case one extra factor c by square root of gamma rt will come. Okay, so this is for the what? Practical scenario. Okay, but if it is not the case, ideal cases, then Cj equal to Ci. Okay, so both the cases I shown. Okay, depending upon the question you can answer the whatever it's required. Okay, so yeah, so the whole idea of doing it is what? The Cj, Ci, all these things depends upon what it's called. This is called your what? Flight velocity. Okay, this is not the inlet, this is not the discharge, this is the flight velocity. Okay, not the inlet or the discharge. So the cycle pressure of ratio of a ramjet depends upon the what? The flight velocity. Okay. Okay. The ramjet engine is self-propelling at zero velocity. Okay. Okay. if there is a self propelling mechanism is there, okay, that means the propeller will is a kind of what you call autopilot mode. Okay, so the if it is autopilot mode is there and it's propelling self propelling, that means it cannot be a zero velocity. Okay, there should be some velocity. Yeah, absolutely, that will, it will be what false. Next question is, the ramjet must be boosted by dash before producing any thrust and at high speed to overcome the drag. Okay. If you're really going to see it, that means there will be some mechanism which can be it will be very easy to answer this question if you really know which kind of mechanism can be added to the ramjet mechanism to enhance the speed. It's a kind of nitro boost, if you can see in the movies on this thing. So if you add these mechanisms, it will actually enhance the speed. Okay, so scramjet is completely a different mechanism, so it cannot be placed with the ramjet. Pulse is also a different mechanism, so these two mechanisms cannot be placed. But yes, ramjet is having a turbine, and we can increase this turbine's power and all this thing by using a turbojet engine. Okay, rather also we can go for a rocket engine also. Okay, by going through a different types of what you called compression ratios, and by enhancing the combustion in the rocket engine, okay, we can enhance the performance of the ramjet engine. Okay, because this is at the because in ramjet the compressor part we don't have any kind of we cannot change anything, but in scramjet and pulsejet this compressor part only going to be changed. Okay, so we have to just now focus on this turbine part. Okay, so or the exhaust part. Okay, so those two things are covered in the turbojet and the rocket. Okay. Okay. So what is boosting means? The ramjet is boosted up to a speed over what? Okay, so that means this answer should be similar to the speed of the it will be obviously less than the speed of the rocket and the speed of the turbojet engine, because we are actually enhancing the speed. It's not like it can work in that range of speed. Okay, so that's the reason these three options, if you see, these are very less speeds are there, only 300 and 500 kilometer per hour. But in rockets and all these things, the velocities are very high, some 5000 or 4000, 10 times more speed. Okay, so yeah, rocket turbojet engine also, I think somewhat 500 to 1000 also, maybe it can be higher depending upon the what kind of turbojet engines they are using. Okay, so whatever, so this answer will be in between the two, 400 and 500, it is 300. Okay, okay, the advantages of boosting a ramjet creates at what? Okay, so boosting, what does this boosting means? Okay, the boosting means I already tell you, producing the thrust and overcoming the drag. Okay, so that means if you are producing the thrust and overcoming the drag, that means the velocity of the mechanism will what? Going to what? Increase. If the velocity will increase, that means you have to create some mechanism or some kind of blockage due to which the pressure is going to what? Decrease. Or more specifically, if I can tell, we have to create one barrier. Okay, and that barrier will increase the what? Pressure. Okay, that means it's the say, if the pressure will decrease, the pressure will increase and the velocity will decrease, that means we have to create a what? Diffuser. So that means the air will enter it at the exit, we have to create one diffuser kind of structure. Like if you see in the rocket engines, there's a kind of diffuser kind of structures are there which will decrease the velocity and increase the pressure, and those mechanisms which will which is just placed at the back of the ramjet as called what do you call so the mechanism for which this thing this whatever this pressure will increase and the air velocity will decrease is called pressure barrier. Okay, the mechanism is called pressure barriering. Okay, pressure, we have to decrease the what? The velocity and increase the pressure. That's the whole idea of pressure barrier in the ramjet engine. So the advantage of boosting the ramjet creates a what? Pressure barrier. Okay. Okay, so the air fuel ratio of the ramjet is what? Okay, if you see, I already shown you that the pressure ratio, that's actually near to somewhat 8 to 10. Okay, and so it's actually more or less similar values if you can expect for air fuel ratio also. But here if you see 10 is not there, so it's slightly higher air fuel ratio. It's actually 15:1. Okay, because all things are related. Okay, in the more or less similar range, all these things are going to work. Okay, so air fuel ratio is your 15:1. That means 15 kg of air required to burn 1 kg of fuel. But yeah, it's actually a general term to what? Write down. it depends obviously on the type of fuel. Okay, if you use methane, the air fuel ratio will be different. If you use hydrogen, the air fuel ratio will be different. Okay, both things, but yeah, in general they are telling 50 minimum. This is, if you more specifically, if you can tell, the minimum pressure ratio is 15:1. That means the fuel which is having higher than 15:1 can be operated with this type of engine, ramjet engine. That means if you see the methane and all this thing, methane, or you can, if you see syngas, methane having some 17.25 is to 1, so it can be operated with the jet engines. And if you see now also in some of the rockets, engines are actually using this kind of methane as the fuel. Okay, so that's what the idea. Maybe in future this methane will be used as the fuel. Okay, methane or hydrogen, all these things can be used. Okay, hydrogen actually it will be somewhat 34:1, so it's very high amount of air is there required for 1 kg of fuel. Okay, that's the idea. Then the question is the exhaust temperature of a ramjet in the range of what? Okay, so actually the ramjet, the exhaust will be very high, but it's not like 5, because you see, if it will be too much high, it will melt the material also. Okay, so it's in the range of 3200 to 3700. Okay, so this is a sweet thing you should remember. Okay, okay, the ramjet's maximum altitude is not limited. Okay, obviously it cannot go to infinite, obviously, so it's actually a false statement. Okay, so because in it's actually it's not a non-air breathing engine, so it need air to operate. Okay, so the moment where the air supply is limited, that point, especially in the space, it cannot operate these ramjet engines. Okay, so the maximum altitude is actually limited for a ramjet engine. Okay, yeah, if it takes, if you're carrying the air within the engine, then it's actually possible. Yeah, because in the question it's not written properly, so you have to only consider the in general what is the case. Yes, if you see in the rocket engines, they are actually, we are carrying this pre-mixed fuels, air and oxidizer mixtures. Okay, so that's the reason why rocket engines are very much popular, and which is a non-air breathing engines. Okay, so the ramjet is not a non-air breathing, it's a air breathing engine, so height is limited. The best performance of a ramjet is observed in the speed range of Mach number. Okay, so basically it's a, always the ramjet will operate in the both in subsonic and supersonic, but in supersonic it occur means it work properly. Okay, so the velocity cannot be very high. Yeah, that means the Mach number cannot be very high or greater than especially 5, where it hypersonic starts. Okay, high 5 to 10 or 10 to 15. This actually we are considering hypersonic flows. Okay, I think if we really see the exact value of hypersonic, so okay, so next, okay, so that means the whatever the scramjet the ramjet is there, it will operate less than 5, which is 2 to 5 is the option. Okay, so yeah, so, so okay, the ramjet is most efficient at high velocity of about what? Okay, so obviously if you really know if you really see this Mach number values, if you can see, it's actually 2 to 5, which gives to a value of what? 600 to some 1600 kilometer per hour. Okay, so yeah, so the best performance of the ramjet is observed in the speed range of 2 to 5, but it does not mean that here actually two things are considered. One is the efficiency, one is the performance. Okay, those two terms are actually very different. Okay, if you are considering this actually this that means in this way the examiner can confuse you. If you see the performance is this, okay, now if you multiply with what the sonic velocity, which is somewhat 300 kilometer, whatever is there, so if you do all these things, then obviously it will be gone wrong. Okay, so what is exactly the case? Okay, 1 2. So don't mix all these things. Okay, so if you consider this whatever sonic velocity, which comes out to be somewhat 1200 kilometer per hour, so yeah, so if you multiply with 2, and then you'll get some range of somewhat 2400 to what, to 6000 kilometer per hour. Okay, so yeah, actually it's actually a option. Okay, so don't direct confuse it also, is meter per second, kilometer per hour. Okay, don't directly multiply 300 with the 2, then the you will obviously get this what you call the C option. Okay, so just to see the units, then actually you solve the question. Okay, The ramjet has nearly no maintenance. Yeah, it's actually a true option because it's not having any kind of moving parts. That's the reason nearly less maintenance. We cannot tell no, but yeah, it's actually having less maintenance, so we'll go for the true. The maximum allowed temperature in the ramjet is, it should be noted that this temperature actually we are talking about the temperature inside the ramjet, or especially in the combustion chamber. Okay, not at the exhaust, because in exhaust the temperature is obviously going to rise. Okay, because it will have more oxidizers when it in the path of the when it's go out of the engine. Okay, so if you see in the previous questions, the exhaust temperature is somewhat 3200 to 3700, very high. But if you so we cannot go for this 3000 and 4000. Okay, and 1000 is extremely less temperature. Okay, so if the exhaust is 3200 means 1000 to 3200 near impossible to achieve. Okay, so 2000 is the more or less similar, we can achieve this much temperature in the combustion chamber. Okay, so the answer will be B. Okay. Okay, so this is actually a very tricky question. Most of the people will go for the true option, and which is absolutely wrong. Okay, because you know very well there in any kind of aircraft engines there will be a speed limit. Okay, so there will be obviously what upper limit, how much high speed it can go. Okay, and we see in the previous options that we see, okay, this is the velocity. Okay, it is operating at this Mach numbers, and 2 to 5, and it can go up to a what velocity of somewhat 2400 to 6000 kilometer per hour. Okay, so now in this course, that means the what is the upper limit? 6000 kilometer per hour. Okay, so that means if you see directly this question, there exists an upper limit to a flight speed, that is absolutely a true option, and you will put a option that is true. Actually, if you choose it, then it's actually going to be wrong. Why? Because this whatever the velocity is that it's actually under the normal operating condition of the ramjet. Okay, and if you really recall what exactly I previously see, so tell you about the velocities. Exactly, if you see here, actually we see that the ramjet engine can be boosted also. Okay, these boosting mechanisms are there through different kinds of turbojet engines and rocket engines. Okay, and when one rocket engine actually involved with the ramjet engine, the speed can be extremely high, let maybe some 15,000 to 15,000 kilometer per hour minimum. This much it can rise. If both turbojet and rocket, both engines, if anyhow we can manage to implement in the ramjet engine, it can be very very high, and the engine will be very very efficient. So it depends on the type of engine what we are implementing, or the boosting mechanism, as well as the type of fuel what we are using, what is the efficiency of those fuels, and how the combustion is occurring. Okay, so there is, it's kind of limitless. We can actually go for any velocity what we can, but the real limitation is the non air breathing. That's the reason we cannot go to the outer space. Okay, but if really the work will going on, means if the really will increase the efficiency and all this thing with different kind of attachments, we can really go for very high velocity for the ramjet. Okay, so the answer is what? B, false. Okay, so when something will take off, okay, that means if the some mechanism will directly take off, especially if you see the helicopters. Okay, so it actually needs some RPM of the what you call rotor blades to rotate, which will push the ground. Okay, and due to the obviously Newton's third law, every action has having equal and opposite reaction, and it will create one very good thrust, and the helicopter will go up into the sky. So and if you see also aircrafts like our aviation, so we get commercial aviation systems. Okay, so there also we actually have required some takeoff thrust, because we need that much velocity, then only it can take some 200 or 300 passengers, and it can take off into the sky. Okay, so always it's required for a what some thrust is required always at the takeoff. Okay, okay, so there is some thrust requirement, okay, for any kind of aircrafts. Okay, okay, that means so now the question is, did this ramjet engine works in the you see the ramjet engine is a steady combustion and continuous flow engine. Okay, so now okay, so now when you see the ramjet engine, okay, the initial thrust, okay, the takeoff thrust or the initial thrust, if it is there, that means initially how it can operate in a continuous manner in the initial state, or especially in the takeoff time. Okay, it cannot operate in the continuous state because it will be very high, it will be increasing order, it cannot be continuous. Okay, so it will be very high thrust will be there, then when it actually take up, then the thrust will be less. Okay, but we know that the ramjet engine always operate in the continuous flow conditions. Okay, so what exactly we are doing here is that in the ramjet engines we are actually for the thrust, increase this means inlet thrust or the takeoff thrust, we are actually using a this kind of turbojet engines. All these engines can be used. Okay, it's actually a option. Okay, this question actually why very much tricky. Most of the people will give answer as answer A. Okay, and if some people know something about this zero thrust conditions, they will actually answer both A and B. Okay, and the both are the wrong options in this questions. Okay, this question is very simple, but the most of the people will do the wrong options. Okay, so basically when this ramjet engine is really going to work, it is when it's already the flight is at the sky, then only this ramjet engine, all this thing will work. So initially we need a other engine, especially one, maybe it can be a turbofan engine or turbojet, especially turbojet engines are used. Okay, to initial thrust we have to overcome, or we can use as a rocket also. Once it go to the a particular height, okay, maybe 30,000 feet or some height, or 10 to 15,000 feet, so there it will actually the real ramjet engine thing will work. Okay, so that's what actually, if you can relate in the previous questions, I tell steady combustion. Okay, that means if the initial conditions, the it's not cannot be a steady combustion, it will obviously be a unsteady combustion, because initially it will combust very high fuel when it want to take off, and when it's in the idling condition, means when there is or when it's cruising at a constant velocity or in constant height, it will have a less fuel consumptions. Okay, as compared to the what it's required for the takeoff. Okay, so all these combines, if you can analyze this question, the ramjet can actually work in zero thrust in the in the time of takeoff. So it's a kind of very tricky question, but yeah, this is the explanation for this type of engine. Okay, if it is a turbojet or all these things, then the absolute answer will be the finite value. It cannot be zero, but for ramjet is actually a possible. Okay, so this is actually a tricky question. So next, the flame stabilization in the combustion chamber of the ramjet requires a Okay, you see, in the ramjet engine works on subsonic as well as supersonic velocities. Okay, but the optimum, what is the optimum performance occurs in which condition? Actually we will see it at nearly very high velocities, like 2 to 5 we just told. Okay, Mach numbers. So if the velocity is very high, that means the chances of blowout will be that will be also high. Blowout leads to instability of the engine. Okay, so that means if you are stabilizing the flame, we need something or some other mechanism so that the flame can be held. Okay, or we can hold the flame so that the blowout won't be there. Okay, so that means it's a kind of if you see some kind of struts kind of mechanism. Okay, or is a kind of some what we are doing, actually we are mixing, how we are enhance the mixing. Okay, as well as we are holding the flame. Okay, some guide vane kind of thing. Okay, which will enhances the mixing by creating some kind of vortex. Okay, either anti-clockwise or clockwise, as well as it will hold the flame. Okay, for that particular engine. Okay, so the flame stabilization in the combustion chamber of a ramjet engine requires a a flame holder. Okay, and it can be anything. It can be a strut, it can be a kind vane. Okay, there is different types of or different kinds of more specifically I can tell this flame stabilization mechanisms are there. Okay, so if you see this option, ramjet are widely used in what? Okay, so obviously low speed is not a correct option, obviously we know that, okay, because it can operate in what? Supersonic flows, okay, but is it really operate in missiles? Okay, because we see that the boosting mechanisms are there, which enhances the, which is by use of what? Turbojet and the rockets. So yes, if we are, I actually already told you that if we are taking the air, because we have to convert this non-air breathing ramjet engine to, sorry, air breathing ramjet engine to a non-air breathing ramjet engine, then we have to take the oxidizer, okay, or the fuel oxidizer mixture with us, so that then we can also go to the what? Outer space, okay. So that means we can actually convert this ramjet engine to a what? Missile, okay. It can be a what you called air breathing missile, okay, or without air breathing missile. If we can underwater also we can operate, okay, if we are really carrying this air, and we can also operate in outer space also if we are actually enhancing this power of this ramjet engine. It's actually very futuristic technology to operate, okay. I think nowadays this technology are actually implementing, and we are, whatever the missiles we are there to make it more efficient, this similar technology used. But yeah, obviously nowadays hypersonic missiles are also there, and the ramjet engine cannot operate in hypersonic velocities, so it's having also limitation. But if you are enhances this combustion to happen, and then we can actually operate it in also what? Hypersonic velocities, okay. So hypersonic missiles also a possible option, or hypersonic aircrafts, fighter jets are also a possible options, okay. So answer will be your C. Okay, so after ramjet we are now studying some about the pulse jet. The pulse jet is similar in construction with what? The pulse jet is similar in construction with the what? Ramjet, okay, similar, but not the same, obviously, okay. The combustion chamber in the pulse jet has a mechanically operated flapper. This is actually the new thing in the what? The what you called pulse jet, okay. Mechanically operated flapper valve grid, okay. This is actually not available in ramjet. This is how we can actually differentiate between the pulse jet and ramjet. So that means if it is a flapper, then what it can do? Flapper means if we see some what do you call some cars, okay. If you see some cars and they are actually above the hood of the engine, there will be some kind of circular kind of mechanisms are there, and when they raise the accelerator, this what you call this one flapper or kind of one butterfly, especially flapper is a butterfly valve, will actually open or close to control the air supply, okay. So into the what combustion chamber or into the engine, okay, whatever. So this flapper mechanism or the valve grid is there, so whenever we want we'll take the air, whenever we don't want we don't take the air, okay. So that's the reason we can control the engine more specifically, and we can operate it in more continuous manner and in more different operating condition. If you see in some condition there air will be lean, and in some cases air will be rich, okay. So all these cases we can operate by the help of this flapper mechanism. So this is actually the one of the advantage of what? The pulse jet engines, okay. Okay, Yeah. So if you see the ramjet, they are actually, I told, constant pressure combustion, but if you see in the pulse jet, it's actually in the constant volume. Okay, because we are actually what do you call, we are actually opening this flapper and closing the flapper. That's the reason we can actually maintaining, if you close the flapper means the volume inside this container is what, constant. But yes, if it is constant, but you see the temperature is rising, the temperature will rise the what, then if the temperature will rise inside this container, the volume will also rise, and if the volume inside this container will rise, obviously the pressure will what, going to rise. Okay, so the pressure rising is possible in the pulse jet engine, but in the case of ramjet, the pressure is what, constant. Okay, so it's actually a constant volume mechanism. Okay, but you know, this is not a, what do you call it, we can make this pulse jet engine to constant volume to a variable volume by what, operating the this flapper. Okay, so that's what the idea. So then the pulse jet is more near to dash thermodynamic cycle. Okay, constant volume means what, it's a Otto cycle. Okay, okay, the ramjet engine develops thrust at zero speed. Obviously nobody can generate the thrust at zero speed. There should be some speed, then only there will be a thrust. It's a very simple thing. Not only ram, any kind of jet engine you can tell. Okay, there will be some that actually requires some velocity, unlike the helicopters. Okay, because their velocity will be less, the height will increase, not the, but it can be, they can place it as actually at a particular what position. Okay, any kind of jet engines you can tell there this condition is not possible. Okay, so pulse jet engine develops a thrust at zero speed. So actually this is the difference between the what, the ramjet and the pulse jet. Okay, but the pulse jet actually, why it can, if it is a true option, then how it can actually operate a thrust at zero speed. Okay, because this is actually the help of what, this flapper mechanism. It can because when we make it as a what, constant volume container, then what it will do, then actually at also very zero means it's not exactly at zero, but at a very low speed also it can actually generate some initial thrust because of this combustion, whatever this constant volume combustion. Okay, so that's the whole idea. Okay, the maximum flight speed of the pulse jet is, this is, it will be little higher. There it's actually 300, it's actually 800 km/h. The pulse jet is widely used as a pilotless aircraft. Actually, it's actually a false option. It's not a pilotless. Okay. Okay, the pulse jet has a lower propulsive efficiency than the turbojet. This is actually a true option. Pulse jet is highly suited for what? Okay, the pulse jet is highly suited for bomber aircrafts. Okay, it will operate in very high speed. Okay, what does these bombers mean? Bombers mean and helicopters target aircraft missiles. Scramjet is nothing but a supersonic ramjet. That's actually a true option. Okay. Okay, just this is the last problem. Okay, we'll solve this. This is little lengthy, but yeah, it's actually involves lots of small problems which can be asked in your exams. Okay, so yeah, we just we'll solve this question, then we'll end the section. Okay, so first we just read the question. In a turbojet unit with forward facing ram intake, the jet relative velocity, the jet velocity relative to the propelling nozzle at the exit is twice the flight velocity. Determine the rate of fuel consumption in kg per second when the developing a thrust of 25,000 Newton under the following conditions. Ambient pressure and the temperature are 0.7 bar and 1 degree Celsius. Compression total head pressure ratio is 5:1. Flight speed 800 km per hour. Cv of the fuel is 42,000 kJ per kg. RAM efficiency is 100%. Isentropic efficiency of the compressor and turbine is 85% and 90% respectively. Isentropic efficiency of the nozzle is 95%. Combustion efficiency is 98%. Turbine pressure ratio 2.23. Assuming mass flow rate of the fuel is small as compared to the mass flow of air and working fluid throughout the system as air, that is Cp of A equal to Cp of the gas equal to 1.005 kJ per kg Kelvin and no pressure loss anywhere. Okay. Okay. So we have to find out the rate of fuel consumption in kg per second. Okay. At a thrust of 25,000 rpm. Okay. Okay, so for this kind of question, first we will draw the cycle, okay, the TH diagram. Okay. This is your ramming. So age is the 0.7 bar and 1 degree Celsius, which is 274 Kelvin. Okay. So let's start the solution. So the flight speed is 800 km per hour. So what is VI? Your 800 into, convert it into what? Meter per second. Flight velocity divided by 3600. So you will get a VI as 2.2 meter per second. Then what is the jet speed of the nozzle? Vj is equal to 2 times bi is equal to 2 into triple 2.2 444 point, I'll put one more 2 meter per second. Let's find out the what, the T1 dash. Okay. If you see T1 is here, and just 1 second. This is not 0, this is 1 dash. Okay. Okay, so now what will be your T1 dash? TA plus BI square divided by 2CP. So 274 is the TA, T1 dash will be your what? Already found 298.57. So now we are assuming the ramming efficiency as what, 100%. P1 equal to not, I am representing at the normal atmospheric conditions. Okay, so T0 1 dash equal to T0 1 when there is ramming. Okay, okay, so what is the P2 dash by P1? It's actually 5. Okay, and what is your P1? 0.9454 bar, and the P2 dash will be 4.724 bar. Okay, so Okay, next will be T2 dash by T1 is equal to P2 dash by what? P1. Okay, gamma minus 1 by gamma. So T2 dash divided by 298.57 is equal to 5 to the power 0.4 by 1.4. So next we will find out the what? The compressor efficiency. Because in the compressor efficiency given and T2 dash we found, then we can, from this formula we can find out what? T2. So substitute and find out T2. So the T3 minus T4 we can now find out the difference in temperature between the position 3 and 4 process. Okay, (205.07 Kelvin). Okay, now we'll know the what you called ratio T3 by P3 and T4 by P4. Okay, just take the ratios. Between the point 3 and 4. T3 by T4 dash is equal to P3 by P4 dash 2 by 7 2.23 to the power 2 by 7 1.2575. Okay, T3 minus T4 divided by T3 minus T4 dash T3 minus T4 divided by T3 minus T3 by 0.2575. Okay, so that means we have a relation of T4 and T3. T4 is equal to 0.81, more specifically 56. Okay, 56 into T3. Okay, and we know the difference between T3 and T4. Okay, we have a difference. You see here we have actually difference, this formula T3 minus T4, this formula and this relation. If you see this, combine these two relation, then we can find out T3 and T4. Okay, so substitute T3 first in place of T4, substitute T3 in the formula before expression. 0.8156 T3 is equal to 205.07 Kelvin. So if you solve, you will get T3 as 2.3 Kelvin and T4 is equal to 907.2 Kelvin. Okay, okay. Okay, now we have we have everything. We just now find out the thrust power, and from there we will find out the m dot f. Okay, by what? By from the what? Inlet heat transfer. Okay, so P thrust is equal to mvi Vj minus Vi. Then if we go for F thrust, put it as m dot Vj minus Vi. Okay, so substitute all these values Vj, Vi and F thrust as given in the problem. M dot F Cv efficiency, combustion efficiency is equal to m dot Cp delta T. Okay, T3 minus T2, because inside if you see in the plot 2 to 3 is the position where the inlet temperature is, sorry, heat addition will be there. Okay, or the Q in will be there. Okay, substitute all the values and find out m dot F. Okay, this is the answer of this question. Thank you very much for attending the section. If you are attending the recording also, thank you very much. If you have any doubts, you can ask in my YouTube channel. Sumit Sagar Hota is the channel name, and you can ask in the comment sections. If you have any doubt regarding the lectures in the NPTEL, you can also ask in the question and answer forum in the NPTEL. Feel free to ask the questions whatever you have, and whatever the questions in my section you have, you can ask in my comment sections if I leave anything. Okay, thank you very much. Good night. We'll meet next week 6 to 8 with the next lecture. week 6. Thank you very much. Have a nice day. Good night.